I had to read this question a few times, to be honest, to get my head around what was going on. So I understand that we've got 7 bars, and they're either going to be on or off, and it's completely random. There's just a probability of zero point 0.5, and then the resultant display, the probability that it correctly shows one of the 10 digits 0 to 9 is what we're trying to work out basically. So let's say like I'm just going to put a given number down like 6. So basically, there's going to be a half chance that that very top one is going to be lit up. And then there's a half chance that that one's going to be lit up, and then a half chance this one, and so on. And a half chance that this one's not lit up. So actually, the probability of getting a 6 when I do it and being like all in the right place is going to be a half to the power of 7. But remember, if I got an 8, that would also count as the result being correct. So there's actually 10 digits that it could be correct. Each one is going to be a half to the power of 7 because it's either, it just has to be on or off for each one. So the answer is going to be a half to the power of 7 times 10. So that is going to be 10 over 2 to the power of 7. 2 to the power of 4 is 16, so it's going to be 32, 64, 128. So 10 over 128. You can divide through by 2, it's going to be 5 over 64. So that is the fraction in its lowest terms, and now we just need to do 9 times 5 plus 2 times 64, which is going to give 45 times 120. Sorry, not times, plus 128, which is going to be 173. So that's how I did this question. The other way you could do it is to work out the number of possible configurations. So because like there's 2 ways of getting this one on or off, 2 ways for this one, and so on, we could actually multiply all of those together. So there are 2 to the 7 ways. And so how many ways are there then of it being correct? Well, there's going to be 10. We get exactly the same answer. I'm just thinking about it using arrangements instead of probability, but it's kind of the same idea. And yeah, that's it for this question.